Hello students, welcome back to the chemistry classes. So we can just revise whatever things that we have studied in the last class, right? Do you remember everything that we have discussed in the last class? Yes, we have discussed about the atomic masses, we have discussed about the molecular masses and the average atomic masses also. Now we are doing with the relative atomic masses. Atomic masses we are finding out using one standard element. Which is that standard element? Yes, we are using carbon 12 as the standard element. Using that carbon 12 isotope, we are comparing the atomic masses of other elements to that of the carbon 12 atom, and we are finding out the atomic masses based upon that. So if we know the atomic masses, it is easy for us to calculate the molecular masses also. Then we have discussed that certain elements are existing in their isotopic form. Several isotopes are there. So in that cases, what we do? We need to consider their relative abundance also. Right? What is relative abundance? Relative abundance is the percentage of that isotope present in that particular element. For example, we are taking carbon. Suppose we are taking 100 gram of carbon. So how much of carbon 12 is present over there? How much percentage of carbon 13 is present over there? And how much percentage of carbon 14 present over there? So that is what the relative abundance of the isotopes. Percentage of each isotope present in that element. Okay. So we have discussed about the average atomic masses also. Right. Then we discussed about the number of moles, calculation of and calculations involving the number of moles also. What is a mole? Mole is a number that will define the number of particles present in it, right? So 1 mole means one Avogadro number of particles in it. What is Avogadro number? 6.022 into 10 raised to 23 particles, right? So 1 mole of any substance, 1 mole of any substance contains Avogadro number of particles present in it, right? So we study the calculations involving the number of moles also. Number of moles is equal to atomic mass by molar mass. What is molar mass? Mass of 1 mole of substance. We call it as a molar mass. So in this topic, we will come across one more term, that is molar volume. What is molar volume? Molar volume is volume of 1 mole of any substance. We call it as a molar volume. But when we are calculating the molar volume, the conditions, the temperature and pressure should be constant. It is at their standard conditions also. Okay. The molar volume of any substance at the STP conditions will be 22.4 liters. So molar volume is 22.4 liters. That is for 1 mole of any substance at the STP condition is 22.4 liters. Okay. So these are all things we have discussed in the last class, right? So today in this topic we are going to study about the calculations involving these number of moles, masses and everything. That we call it as a stoichiometry. Stoichiometry calculations, and also about the limiting reagent also. Okay, so let us watch it.
So let us learn about the stoichiometry today. What is stoichiometry and how do we do calculations, numerical problems that is involved in the stoichiometry? That all things that we are going to discuss today. Now, stoichiometry is derived from two Greek words. It is derived, the stoichiometry, that term is derived from two Greek words. What are those two Greek words from which the term stoichiometry is derived? It is stoichion and metron. Okay, it is derived from two Greek words, stoichion and the metron. What does the stoichion means? Stoichion means elements. Stoichiometry means elements and metron means measure. Metron means measure. How can we define stoichiometry? We can define the stoichiometry as stoichiometry deals with the calculation of masses of reactants and products involved in a chemical reaction. So stoichiometry is involving, it deals with mainly the calculation of masses of reactants and products in a chemical reaction, the reactants and products masses calculation. That is what we are studying under stoichiometry. Let us look an example. CH4 plus oxygen, methane plus oxygen gives carbon dioxide and water. Okay, check whether it is balanced. Right, it is balanced chemical equation. Right, at the end, in each reactants and the products, we have to mark it. You know that left side that we call it as the reactants. Which are the reactants present over here? Methane and oxygen. And the products are carbon dioxide and water. So it is a balanced chemical equation. Now check in which state it is existing. All are in their gaseous state, right? So gaseous state, right? CH4, it is in gaseous state. So we'll mark in which state it is in at the bottom of the each reactant and the product, right? Gaseous state, so we mark it as a G, and if it is in solid state, we will mark it as S, and if it is in liquid state, we will mark it as the L, right? So here all the reactants and the products are in the gaseous state. Okay, it is a balanced chemical equation. Then every reactants and the products are in the gaseous state too. Now we can check how we can do the stoichiometric calculations using these particular chemical equation. How can we find out the masses of these reactants and the products? Let us discuss what all informations that we get from this particular balanced chemical equation. Okay, CH4. Look at the number of molecules present in it. How many molecules of reactants and products are present in it? We can just look at that one right now. Okay, CH4 molecules. How many molecules of CH4 is present? One molecule, right? One molecule of CH4 is reacting with two molecules of oxygen to give out one molecule of carbon dioxide and two molecules of water, right? That's the first information that we will get from this balanced chemical equation. Before writing the informations in this particular chemical reaction, make sure that it is balanced. Okay, so one molecule of CH4 reacting with two molecules of oxygen to give out one molecule of carbon dioxide and two molecule of water, right? This is correct, right? This everyone knows it, right? So one molecule of CH4 is reacting with two molecules of oxygen to give out one molecule of carbon dioxide and two molecule of water. Now let us check the number of moles involved in this chemical reaction. To find out the number of moles, I am multiplying it with the Avogadro number. Avogadro number we are expressing using the Na, right? Because we know that number of particles is equal to number of moles into Avogadro number. So I'm just multiplying it with the Avogadro number to find out the number of moles. Okay, so the first one is number of molecule is 1, right? So we can write the number of moles as 1 Na, right? The other one 2 Na, right? Then carbon dioxide only one molecule is present, so simply Na. Then 2H2 is present, so I write it as 2Na, right? So what is this Na? This is Avogadro number. So 1 mole of any substance contains Avogadro number of particles in it. So Na represent 1 itself, 1 mole, right? Then what about 2Na? That means 2 Avogadro number, 2 into Avogadro number. So 1 mole of any substance contains Avogadro number of particles. So 2Na means it contains 2 moles present in it, right? Then Na, simply the Avogadro number. So it contains only 1 mole of particle. 2Na. 2Na means it contains 2 moles of particle present in it, right? So this is how we are representing the chemical reaction using the Avogadro number to find out, express this chemical reaction in terms of moles. So it is clear that 1 mole of CH4 is reacting with 2 mole of oxygen to give out 1 mole of carbon dioxide and 2 moles of water, right? So the ratio with the number of moles also we have got, right? Now, can we get the information about the masses from this chemical reaction? Yes, that's also easy, right? We can get the information about the masses also from this chemical reaction. CH4, find out the total molecular mass of CH4. You know how to find out the molecular masses, right? Carbon 12 plus 4 into 1, right? Atomic mass of hydrogen is 1. So we'll get total 16 gram of CH4. Make sure that it is correct. Okay, just calculate it and find out the molecular mass of CH4. It will be 16 gram. Then 2O2, oxygen, single oxygen atom has a atomic mass of 16. So 16 into 2, then into 2, right? So total 4 atoms of oxygen are there. So it will be 32 into 2, that is 64. Carbon dioxide 44 gram, carbon 12, oxygen 16, right? 12 plus 16 into 2. Then H2O, 2 into 18, right? 2 into 18. So I hope you remember how to calculate the molecular masses of these compounds. Otherwise, if you're having any confusion, go back to the last video that I have posted and check whether how we are finding out the molecular masses of the compounds, and make sure that the masses that I wrote over here is correct. It is clear from here that 16 gram of CH4 is reacting with 64 gram of oxygen to give out 44 gram of carbon dioxide and 36 gram of water. Next is about how we can relate it with the volumes. Okay, volumes. Volume. This is a topic that I forgot to mention in the last class. Volume is a standard quantity. That means 1 mole of any substance. 1 mole of any substance contains, if all the substances are in the gaseous state, if 1 mole of any substance contains 22.4 liters. It's constant. It's volume. So 1 mole of any substance is occupying a volume of 22.4 liters, provided that all the conditions are at STP. Okay, the temperature, pressure, everything should be at the standard condition. Then molar volume, we call it as a molar volume. Volume of 1 mole of any substance is occupying a volume of 22.4 liters. So just look at over here, CH4, 1 mole only, right? So it is occupying a space of 22.4 liters, provided that everything is in STP condition. Then 2O2, it contains 2 into 22.4 liters. Carbon dioxide only 1 mole present, so it is occupying a volume of 22.4 liters. Then 2H2O, that means it contains 2 into 22.4 liters of volume. So these are the main informations that we are getting when we are having a balanced chemical equation. These all informations that we are getting from a balanced chemical equation. So we can define a chemical reaction in many ways, in terms of number of molecules, in terms of number of moles, in terms of masses, or in terms of volume also we can define a particular chemical reaction. But make sure that before you're defining, that chemical reaction is balanced. Now let us do one numerical problem. Let us try to solve it. Okay, so the question is, calculate the amount of H2O produced by the combustion of 16 gram of methane. So H2O is in the gaseous state. Okay, so our aim is to calculate the amount of water produced when 16 gram of methane is undergoing combustion reaction. So the first thing that you need to do when you're getting a stoichiometric calculation is to write the balanced chemical equation for that reaction. Okay. So one thing I will tell you now itself, so when you're getting a numerical problem in chemistry, make sure that you write all the steps needed for that numerical problem. When I'm taking the numerical problems classes, I will tell you which all steps that is mandatory when you are doing one numerical problem, because for the board examinations marks will be given for the steps also. So in the +1, it's in the first year itself, make sure that you practice like that itself. Okay, make sure that you are writing all the steps that is needed for that calculation. Okay, now look at our reaction. It is no combustion of methane, right? The reaction is combustion of methane. What is combustion reaction? It's a reaction with the oxygen. We all know it, right? So methane is undergoing combustion reaction means methane is undergoing reaction with the oxygen, right? So CH4 in the gaseous state plus combustion reaction is a reaction with the oxygen O2 gives. We know the products of the combustion reaction also, right? What are the products? Carbon dioxide and water, CO2 and H2. After writing the chemical reaction, what is the next step? Make sure that this chemical reaction is balanced. Okay, so look at each of the elements. Carbon is already balanced. Hydrogen, only the problem with the hydrogen, right? So hydrogen, now it is balanced, but now the oxygen, number of oxygen atom is no, should be balanced. So now it became a balanced chemical equation. So first step, you need to write the chemical reaction. Next step, you need to balance it. Okay, after balancing, make sure that one more time you try and check whether it is undergoing, no, it is in the balanced state. Now, what do we need to find out? We have only one information is given is about the amount of methane. Methane is 16 gram. What is the thing that we need to find out? We need to find out the amount of water produced. Okay, so it's a relation between the methane and water. So we need to look at only those substances, methane and water alone. Okay, now how much of methane is present over here? 16 gram of methane is present over here, right? So using the 16 gram of methane, how much of water is getting produced? That is what we need to find out. So we are supposed to relate only methane and water. Now look at the number of moles of methane and water. Methane is 1 mole only, right? Methane is 1 mole and water is 2 moles are present over here. Now we need to relate it in terms of grams because methane gram is given over here. 16 gram of methane. Find out the gram of CH4 over here. CH4 carbon 12 plus 4, that is 16 gram itself, right? Now water, how much of water is, so our question is also what is the amount of water produced when 16 gram of methane is undergoing combustion, right? So it's just a direct question. So when 16 gram of methane is undergoing combustion, how much of water is getting produced? Find out the molecular mass of 2H2. You will get the answer as 36 gram. So 16 gram of methane when it is undergoing combustion reaction can produce 36 gram of water. So that is the answer for this question. So amount of water produced is 36 gram of H2O. So likewise you need to do it. So let us do next problem. Let us do the next problem. How many moles of methane are required to produce 22 gram of carbon dioxide after combustion? Okay, so here you need to find out the number of moles of methane required to produce 22 gram of carbon dioxide after combustion. So here also methane is undergoing combustion. So write the balanced chemical equation for this reaction. We already done it, so I just writing it. CH4 plus 2O2 gives CO2 plus 2H2O. So methane is undergoing combustion. Now let us check which all substances that we need to relate. We need to find out the number of moles of methane and we need to relate it with the carbon dioxide, right? So we need to relate methane and carbon dioxide. Okay, first you need to write the number of moles of this reactant and the products. CH4, how much moles of CH4 is present over here? 1 mole of CH4 is undergoing combustion, right? So 1 mole of CH4. How much of carbon dioxide is produced over here? Again 1 mole carbon dioxide is produced. So it's clear that 1 mole of CH4 is producing 1 mole of carbon dioxide. Now what is the information that is given to us? How many moles of methane is required to produce 22 gram of carbon dioxide? So CH4, we need to find out the number of moles of methane. So write the number of moles of say methane as it is 1 mole, right? But carbon dioxide amount is given in terms of mass. So we can also write the number of total mass present in the carbon dioxide. It is 44 gram. And 44 gram of carbon dioxide, because whatever that information that is given in the question, you have to write it like that. You need to find out the methane in terms of mole, so I wrote it 1 mole. You need the information that is given, the data that is given in the question is in terms of gram of carbon dioxide, so I wrote the gram of carbon dioxide, that is 44 gram itself. Now, we need to find out the number of moles of methane produced when 22 gram of carbon dioxide is produced, right? The number of moles of methane required to produce 22 gram only. So, let the unknown value of CH4, we can write it as a X. Okay. Now, what we need to do? 1 mole of CH4 is producing 44 gram. So, how much methane is required to produce 22 gram of carbon dioxide? What we need to do? We can cross multiply it. We can take the ratios, right? We can cross multiply it. 1 into 22, then x into 44. 1 into 22 is equal to x into 44. So we'll get the value of x from there, right? So x will be equal to 22 into 1 divided by 44. Right? Write the units also. 44 is in gram, 22 is in gram, 1 is in number of moles. So we'll get the value of x as 0.5 moles. But for this question, it is clear that 0.5 mole of CH4 is needed to produce 22 gram of carbon dioxide. But when you look at this question, it is very simple to calculate, because it's just exactly the half of the carbon dioxide, right? Carbon dioxide initially it was 44 gram, now it is 22 gram, just the half, right? So 1 mole is required to produce 44 gram of carbon dioxide, so just the half, right? Then we can simply, from this question itself, it is clear that 1 can produce 44, then half can produce the 22 gram. So for this question it is very simple, but otherwise when it is normally exactly the half won't be given, so it's better that you take the ratio and do it. Now, let us discuss about the limiting reagent now. What is this limiting reagent? We can now explain the limiting reagent using a chemical equation. So, I wrote the chemical equation also over there. H2 plus Cl2 gives 2HCl. Now, what is this limiting reagent? Suppose here we can just compare the number of moles present in this chemical reaction. Here Cl2 is 1 mole of H2 is there, 1 mole of Cl2 is there, and it is producing 2 mole of hydrochloric acid. Okay, so here 2 moles of hydrochloric acid is there. Suppose I need to produce 4 moles of hydrochloric acid. In order to produce 4 mole of hydrochloric acid, is it necessary to change only one of the reactants? Suppose if I need to produce 4 HCl, no, do we get 4 HCl by changing the number of moles of chlorine alone? Right? That's my question. So in order to produce the 4 moles of HCl, is it only required to change only one of the reactant, or do we get 4 moles of HCl by just changing the number of moles of chlorine alone, by keeping the other reactant, that is by keeping the number of moles of hydrogen constant, by changing the number of moles of chlorine, do we get the hydrochloric acid, the desired number of moles for the hydrochloric acid? No, that is not possible, right? So if you are keeping the number of moles of hydrogen as a constant, if you are not changing it, what will happen means, one of the reactant is an excess quantity, but we have increased the amount of chlorine, but the other one, that is the hydrogens, the amount of hydrogen is limited, right? The amount of hydrogen is less, so it will not allow the chemical reaction to proceed, because what will happen over the when the reaction is proceeding, since the amount of hydrogen is less, even though amount of chlorine is very high, but the amount of hydrogen is very less, so what will happen? Hydrogen will get consumed fast. In this chemical reaction, hydrogen will get consumed fast, and what will happen if there is no hydrogen? Then what will happen? The chemical reaction won't takes place further. So if the amount of hydrogen is less, we won't get the hydrochloric acid also. So that element, that reactant, here in this case it is hydrogen. So that reactant which limits the amount of product produced, we call them as the limiting reagent or limiting reactant. Why is it called limiting reactant? Because it will limit the amount of product formed, right? It will limit the amount of product produced in a chemical reaction. Okay, now how can we define a limiting reactant? Limiting reactant are those reactant which will limit the amount of product formed, or we can say that limiting reactant are those reactant which is present in lesser quantity, if that is present in the lesser quantity, what will happen? When that reactant is consumed, it won't no it that further chemical reaction won't takes place, so it will limit the amount of product formed also. That reactant we call it as the limiting reactant. Okay, so even though if we are adding more and more, if we are taking lot of chlorine, there is no use at all, because we need to increase the amount of hydrogen also. Otherwise what will happen? Hydrogen will get consumed fast, and it then further reaction won't takes place. That type of reactant we call it as the such type of reactant we call it as the limiting reactant. Let us discuss the next question. 50 kg of nitrogen and 10 kg of hydrogen are mixed to produce ammonia. Calculate the amount of ammonia formed. Identify the limiting reagent in the production of ammonia in this situation. Okay, so we need to identify the limiting reagent. After finding out the limiting reagent, we need to find out the amount of ammonia produced also. Okay, so what is the first step that we need to do is write the balanced chemical equation for this reaction. So it's a reaction between nitrogen and hydrogen to produce ammonia. So it's a reversible reaction. N2 plus H2 gives NH3. Then what is the next step? Yes, we need to balance it. Balance that chemical reaction. So we will get N2 plus 3H2 gives 2NH3. Now it is balanced. Okay, now we need to identify the limiting reagent. That is the first step. We need to identify the limiting reagent. Now, how do we identify the limiting reagent? Okay, after finding out the limiting reagent only, we can calculate the amount of ammonia formed. Okay, so we are going to find out the limiting reagent in this reaction. So first thing that we need to do is find out the number of moles of the reactants. Number of moles of nitrogen. Number of moles is equal to mass by molar mass. What is the mass of nitrogen? It is 50 kilogram. Make sure that it is in kilogram. So we need to convert it into gram. Right? So how do we convert into gram? 50 into 10 to the power of 3 divided by, what is the molar mass of N2? It is 14 into 2, that is 28. What is the unit? Gram. Gram per mole. Okay, so when we calculate it, we will get the number of moles of nitrogen as 1.785 into 10 raised to 3 moles. Now we got the number of moles of nitrogen. Next step is we need to find out the number of moles of hydrogen. Okay, number of moles of hydrogen is equal to, again, mass is 10 kilogram, so we need to convert into gram, so it will be 10 into 10 raised to 3 divided by, what is the molar mass of H2? Here I am taking exactly the same atomic masses, exact value I am taking. So we will get the molar mass of H2 as 2.016. So when you do the calculation, you will get the number of moles of hydrogen as 4.96 into 10 raised to 3 moles. Now we got the number of moles of nitrogen and hydrogen present in this reaction depending upon the amount of nitrogen and hydrogen we are taking. Now, actually, what is the number of moles needed for the nitrogen and hydrogen that we need to find out now. According to the balanced chemical equation, the ratio between nitrogen and hydrogen is 1:3, right? 1N2 and 3H2. So, exactly the ratio between nitrogen and hydrogen is 1:3. Just check whether the number of moles that we got is in the same ratio. We know that number of moles of nitrogen we got it is 1.785 into 10 raised to 3 moles. So according to the balanced chemical equation, if the number of moles of nitrogen is 1.785 into 10 raised to 3 moles, then the number of moles of hydrogen should be 3 into number of moles of nitrogen, right? Okay, so what do we got? What are we going to get as the number of moles of hydrogen is 5.355 into 10 raised to 3 moles. Okay, so this is the number of moles of hydrogen that is supposed to be get when we are having the ratio 1:3. So actually, if there is 1.785 into 10 raised to 3 moles of nitrogen is there, means there should be 5.355 into 10 raised to 3 moles of hydrogen should be there. But we don't have that much of hydrogen with us, right? We have only 4.96 into 10 raised to 3 moles of hydrogen with us. So which one will be the limiting reactant over here? It will be the hydrogen itself, because hydrogen, the amount of hydrogen is very less when compared to the actual volume of hydrogen that is needed for this chemical reaction. So this is how we are finding out the limiting reactant. So the limiting reactant here, it is hydrogen itself. Okay, so we have wrote the chemical equation, then found out the number of moles of nitrogen and hydrogen, and checked whether it is in the same ratio as that is given by the balanced chemical equation. That is the main important thing. I hope till this it is clear for you, right? So the limiting reactant of this reaction is the hydrogen itself, because hydrogen, amount of hydrogen is less than that is actually needed for this chemical reaction. So hydrogen is the limiting reactant. Now we need to find out, the next step is we need to calculate the amount of ammonia produced over here. So which is a limiting reactant? Here the limiting reactant is hydrogen, right? So we need to compare the hydrogen. Using the hydrogen, how much of ammonia is produced? Because hydrogen is a limiting reactant, it will limit the amount of ammonia produced. So we need to compare the hydrogen with the amount of ammonia produced. Okay. So in the chemical equation, it is 3 moles of hydrogen is producing 2 moles of ammonia. So it is in the ratio 3:2, right? 3 moles of hydrogen is producing 2 moles of ammonia. But here, how much of moles of hydrogen is there with us? Here we have 4.96 into 10 raised to 3 moles of hydrogen is only is present. So how much of ammonia is produced over here? So the amount of ammonia produced, we can write it as x. Let it be x. Okay, so we can find out the value of x, right? Again the cross multiplication, you will get the value of x as, so x will be equal to 4.96 into 10 raised to 3. We are cross multiplying it, okay, to find out the value of x. 4.96 into 10 raised to 3 divided by 2, into 2 divided by 3. So we'll get the answer as 3.307 into 10 raised to 3 moles. Okay, now we got the number of moles of ammonia is producing right? So actually we need to find out the amount of ammonia produced. So we need to find out the amount of ammonia produced. So now we got the number of moles of it. Using the number of moles calculation, we can find out the mass of ammonia produced also, right? Number of moles is equal to mass by molar mass. So using that equation, we can find out the mass of ammonia produced, right? So number of moles is 3.307 into 10 raised to 3. That will be equal to, that is the number of moles masses, number of moles into molar mass. Then number of moles is 3.307 into 10 raised to 3. That's into molar mass of ammonia, it is 17 gram per mole. So you will get the mass of ammonia produced is, when we do the multiplication, we'll get the answer as 56.2 into 10 raised to 3 grams. So all the values were there in the question. All the values were given in terms of kilograms. So we can also change it in terms of kilograms. So it will be 56.2 kilogram, because nitrogen and hydrogen, all the masses are given in the question is in terms of kilograms. So we can also change it in terms of kilograms. So 56.2 kilograms of ammonia is producing. So this is how we are doing the stoichiometric calculations and limiting reagent calculations. I hope you have understood it. Watch this. This is an most common example that we are doing. If you study this example, you can do all the calculations. Again, I will give you some of the questions, then try to solve it. Thank you.